In this video, I want to talk about the covalent structure. Is section 3 of chapter 4 for your IB textbook. At the end of this section, you must be able to draw the Lewis structure for both molecules and the ions. You must be able to find total valence electron for them. At the same time, by the Vesper theory, you must be able to predict what is the electronic geometry and molecular geometry for the both molecules and the ions. And based on that, you must be able to predict the bond angles for the molecules, and based on the shape of the molecule and the bond polarity, you must be able to talk about the polarity of the molecule, if the molecule is polar or not. And you must be able to draw the resonance structures for the different molecules, including these three molecules which are mentioned here. The last thing that you must know at the end of this chapter, in this section, sorry, is the properties of what we call giant covalent compounds. Okay, these compounds are new for you. You have not studied it last year. So let's go and to talk about the Lewis structures. You are familiar with the Lewis structures. The Lewis structure shows the electrons on the valence layer of the atom which are in the molecule, and they show it how they share the electron, how the electrons are distributed between the atoms, if they form the single bond, double bond, and so on. So there are several steps for the drawing the Lewis structures. These steps are mentioned here because you have know them from the last year, so I don't go into that one. So directly I go and I do some drawing for knowing the Lewis structure. Okay, so we practice on the Lewis structure of CCl4. We start from that one. So the CCl4, the first step is to find total valence electron for that. So we know that the valence electron of the atom relates to their group in the periodic table. The carbon is in group 14 of the periodic table here. So it has 4 valence electron. Chlorine is belong to group 17 or hydrogen, so it has 7 valence electron. So you need the periodic table to find the total valence electron, and the periodic table is given to you because this type of the questions comes in the paper 2 in the IB. And you know, for the paper 2 you have the IB data booklet, so you can easily use this table for finding the valence electron of the atoms which are available inside your molecule. So let's move on here. Okay, carbon is in group 4, so it has 4 valence electron. Chlorine is in group 17, it has 7 valence electron, but because we have 4 chlorine, so we multiply 7 by 4. So total valence electron here becomes 32. So we have 32 valence electron. The next step is to identify which atom come to the center, which we call it central atom. By the general rule, atom which is less electronegative comes to the center. So if you have group 2 atoms, like this case in group 2, in group 14, and in group 17, group 14 atom comes to the center. And usually when you have the chlorine, when you have the carbon, carbon is the central atom. So the carbon is the central atom. You draw the single bond between the central atom and the rest of the atom. You have 4 chlorine, so I draw the single bond between the carbon and chlorine. The next step, I have to make all of the atom octets. The carbon at the center is already octet because it has 2, 4, 6, and 8 electrons. You know that each of the bonds represents 2 electrons, or a pair of the electrons. But each chlorine here, they have only 2 valence electrons, so we have to add the electrons to that to make them octet. So this chlorine becomes octet, this one becomes octet, we made this one octet, we made these one octets. Okay, so now all of the atoms satisfy the octet rule. But we have to calculate the electrons that we have here in these structures and check if it's equal to 32 or not. Okay, so for each of them you can count the electron 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So you have 32 electrons, same as total valence electrons. So this is the correct Lewis structure for CCl4. Let's go to the next molecule. Okay, so before going to the next molecule, you can show also the lone pair by the line. So each line represents a pair of the electron. Okay, or you can show the electrons by the cross. So all of these are possible for the drawing the Lewis structure. Okay, so let's draw NH3, then H2O, CO2, and HCN. So I draw the Lewis structure for them. Okay, Lewis structure of NH3. The first step, finding total valence electron. Nitrogen is in group 15, so it has 5 valence electron. Plus you have 3 hydrogen, each one of them has 1 valence electron, so total valence electrons are 8. Hydrogen never can come to the center, so the hydrogen is never central atom. So that's why the central atom here is nitrogen. We put the single bond between the central atom and the rest of the atom that we have. We have 3 hydrogens, so we put a single bond between the nitrogen and hydrogen. We have to make the atoms octet. The nitrogen has 2, 4, 6, 8. We put 1 lone pair for that to becomes 8. We are not allowed to make the hydrogen 8 because the hydrogen is in the first period and it has only one s orbital. Maximum number of electron in the 1s orbital is 2. So when the hydrogen has 2 electrons, it's okay for the hydrogen. Okay, now let's count the electron, check if it's 8, same as total valence electron. Okay, 2, 4, 6, 8, same as total valence electron. So this is the correct Lewis structure for NH3. Okay, one point that I want to mention here is that these electrons which are shared between the nitrogen and hydrogen belongs to both of them. So that's why I say 1, 2, 3, 4, 5, 6, 7, 8. So I count all of these electrons in the bond for the nitrogen. And at the same time, for each hydrogen, I say they have 1, 2 electrons. So the shared electrons now belongs to both of the atoms. Okay, so what was the next? H2O. Let's draw the H2O molecule. We follow the same step. H2O, total valence electron. You have 2 hydrogens. So each hydrogen has 1 valence electron. And you have 1 oxygen. Oxygen is in group 16, so it has 6 valence electron. Total valence electron becomes 8. So you have oxygen, single bond hydrogen, single bond hydrogen. You have to make the atoms octet. The oxygen has 1, 2, 3, 4. So we need to put 5, 6, 7, 8. So we need 2 lone pairs for the oxygen to become octet. And the hydrogen, they already have 2 electrons, so it's okay for the hydrogens. Now let's count the total valence electrons that we have. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 valence electron in this structure. So this means that this Lewis structure is correct. Okay, the next molecule is CO2, carbon dioxide. The total valence electron for the carbon dioxide. You have 1 carbon. Carbon is in group 14, so you have 4 valence electron for that. Plus 2 oxygens, 2. Oxygen is in group 16. So for each oxygen you have 6 valence electron. So totally you have 16 electrons in the valence layer. So what we do, we put the central atom. The central atom is carbon. We draw the single bond between the carbon and the other atom, oxygens in this case. We have to make the molecules, we have to make all of the atoms octet. Let's start from the oxygen at the left side. It has 1, 2, 3, 4, 5, 6, 7, 8. The carbon 1, 2, 3, 4, 5, 6, 7, 8. The oxygen at the left 1, 2, 3, 4, 5, 6, 7, 8. So now all of the atoms become octet. Let's count the electrons. If you count the electrons that you have here, you can see that you have 20 electrons. It means in this Lewis structure we have drawn 4 extra electrons. So this is not correct Lewis structure. What we can do in this case, where the number of the electrons in our structure is more than the total valence electron. In that case, cancel a lone pair on the central atom. So I cancel these lone pair on the central atom, and I bring the lone pair from the adjacent atom between them. So the oxygen is adjacent atom to this carbon, to the central atom. I bring it here. Okay. So now the number of the electrons becomes 18. Still I need to cancel 2 more electrons. So I cancel these lone pairs as well. Now I bring these electrons here. So the correct Lewis structure for this one would be carbon. It had 1 bond here with the oxygen, but because these electrons are come here, so it becomes the double bond. And this oxygen, for this oxygen, 2 lone pair remains. So 1 lone pair, 2 lone pair. Same thing happens here between the carbon and oxygen at the left side. Now the bond becomes double bond, and the oxygen has 2 lone pairs. Now if you count the electrons on each atom here in this structure, so for example look at the carbon, it has 2, 4, 6, 8, so it's octet. Look at the oxygen at the left side, it has 2, 4, 6, 8, so this one also becomes octet. So both of these oxygens and the carbon is octet, and if you count the electron in this structure, it becomes 16. So this is a correct Lewis structure for carbon dioxide. Okay, so the next molecule is HCN. Let's come back here to our whiteboard or OneNote. HCN, total valence electron for that. Hydrogen is 1, plus carbon is in group 14, so it's 4. Nitrogen is in group 15, so it has 5 valence electrons. So the total valence electron is 10. As I said, when you have the carbon, carbon comes to the center. You put the single bond with hydrogen, single bond with the nitrogen. We make all of them octet except the hydrogen, which has 2 electrons. So the carbon becomes 2, 4, 6, 8. The nitrogen 2, 4, 6, 8. So all of these atoms become octet. The hydrogen becomes 2. Now let's count the electrons that we have here. So 2, 4, 6, 8, 10, 12, 14. We have 14 electrons. So it means we have 4 extra electrons. So we have to cancel 4 lone pairs on the central atom. So when we cancel the lone pair, we bring the lone pair from the adjacent atom between here. We cancel more 2 electrons. We bring 1 lone pair here. So the correct Lewis structure would be this one: H, carbon. It had 1 bond here already. 2 more lone pairs comes here, so it becomes triple bond. Nitrogen, and only 1 lone pair remains for the nitrogen. So now if you look at the carbon, it has 2, 4, 6, 8 electrons. The nitrogen, 6 electrons here, 2 electrons here, so it also becomes 8 or octet. And if you count the electrons are 14 the electrons that you have here in this Lewis structure is 10. So this is the correct Lewis structure. Okay, we can use the same method for drawing the ions. So look at here. Here we have OH minus and SO42 minus. So let's draw the Lewis structure for these two ions. We call them polyatomic ions. It means several atoms are covalently bonded to each other, but they have charge. So the polyatomic ions are charge group of the atoms which are covalently bonded to each other. So let's draw the Lewis structure for OH minus here. The OH minus, total valence electron. You have oxygen in group 16, so it has 6 valence electron. Hydrogen is in group 1, has 1 valence electron. But look at here. Here you have the negative. It means the atoms has gained 1 extra electron. So we have to add 1 electron here. So the total valence electron in OH minus is 8. So we have 8 electrons here. You have 2 atoms, so it's not important which one you consider it as a central atom. So we just draw the 2 atoms and we put the single bond between them. Then we make the atoms octet. The oxygen, it has 2, 4, 6, 8, and the hydrogen has 2 electrons. And when we count the electrons here in this structure, 2, 4, 6, 8, same as what we have here. So this is the correct Lewis structure for OH minus. Let's draw the Lewis structure for the SO42 minus. SO42 minus is the sulfate ion. So let's find the total valence electron for that. Total valence electron. Sulfur is in group 16, so it has 6 valence electron. We have 4 oxygen. Oxygen is in group 16, so it also has 6 valence electrons. But here we have 2 minus. It means all of these atoms has gained 2 extra electrons. So we have to add to the number of the electrons, plus 2. So the total valence electron would be 32 electrons. Okay, so between these two atoms, which one comes to the center? So if you look at group 16, at the top of group 16 you have oxygen, then below it's sulfur, selenium, and so on. And you know that the electronegativity decreases when you are going down the group. So the sulfur's electronegativity is less than oxygen. That's why the sulfur come to the center. So the sulfur come to the center. We have 4 oxygen atoms, so we draw a single bond between the central atom and these 4 oxygen atoms. Okay. Now we have to make all of the atoms octet. For the sulfur here, it has 2, 4, 6, 8. So it has its 8 electron. It's already octet. So we don't need to do anything for that. For the oxygens that we have here, so let's start with these oxygen. It has 2, 4, 6, 8. We made it octet. The sulfur that we have here, 2, 4, 6, 8. The sulfur and oxygen that we have here, 2, 4, 6, 8. And for the oxygen at the top, this is 2, 4, 6, 8. So we made all of the atom octet. Now it's time to count the electrons and check if it's 32 or not. So if you count all of these electrons that you have here, you can see that there are 32 electrons. So this is the correct Lewis structure for the sulfate ion. But when you have the ion, you must draw this Lewis structure inside the bracket and show the charge of the polyatomic ion here. So it's 2 minus. We have to do the same thing for OH. We have to put it in the bracket and put the negative sign here. So these are the correct Lewis structure for the hydroxide ion and for the sulfate ion. Okay, let's go back to the textbook. Okay, it says in coordinate bonds, both shared electrons come from one atom. So the question is, what is the coordinate bond? Okay, again, this term is new for you, so I will explain what is the coordinate bond. although you had it last year, but you didn't know its name. Okay, let's answer the question about the coordinate by one example. So I want to draw the Lewis structure for ammonia or ammonium NH4 plus. Okay, so let's find the total valence electron for that. Nitrogen is group 15, so it has 5 valence electrons. Plus you have 4 hydrogen, each one of them has 1 valence electron. Here you have a positive charge. It means all of these atoms had lost one electron. So we have to subtract 1 from these electrons. So the total valence electron for this compound becomes 8. Nitrogen come to the center because the hydrogen cannot be the central atom. You have 4 hydrogens, single bond hydrogen, single bond hydrogen, single bond hydrogen, single bond hydrogens. Now check if they become octet or not. The nitrogen has 2, 4, 6, 8 electrons, so it's octet, and each of the hydrogen they have their 2 electrons, so they are okay. And the total electrons is 8, same as total valence electrons, so this is the correct Lewis structure. All we have to do is to put it inside the bracket and put the positive charge here on the surface. Okay, but the question is, the nitrogen has 5 valence electrons, so it means if it shares only 3 electrons it becomes octet, it becomes 8. So why here the nitrogen forms 4 bonds? Okay, so actually one of these bonds, the electron is not shared between the nitrogen. The electrons are not shared from both atoms. Okay, so let me explain it here. So what do you have in ammonia? NH3. The total valence electron nitrogen is 5. You have 3 hydrogens, so you have 8 valence electrons. You have nitrogen, single bond hydrogen, single bond hydrogen, single bond hydrogen, and you have to make the nitrogen octet, so 2, 4, 6. You need 1 lone pair here. Okay, and if you count the electron it becomes 8. So it's okay for the nitrogen to only share 3 electrons. So actually nitrogen has 5 valence electrons. 2 of those valence electrons are here. The one is here, the next one is here, the next one is here. And you have hydrogen, 3 hydrogen, each one of them has 1 valence electron. So this is valence electron of hydrogen, hydrogen, and hydrogen. Now compare this structure with this one. So what happens? You have 1 extra hydrogen here. So it means what happened here? Here actually the H plus comes here, and this nitrogen shares its lone pair from one side with this H plus. Okay, you know that the hydrogen has 1 electron, so it's 1s1. In its 1s orbital it has only 1 electron. When it becomes H plus, these electron goes, so it doesn't have anything in the 1s orbital. Okay, so now it can accept 2 electrons here. So that's why when you have H plus, it has 1 free orbital which can accept the electron from the nitrogen. When it accepts the electron from the nitrogen, it becomes N, H, 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 and these lone pairs which was here, now it's shared with the H plus. To this bond, which the both electron comes from only one atom, is called coordinate bond. Okay, so the bond which both of the electrons comes from the one atom is called the coordinate bond. So they are same as the covalent bond. So if you look at the molecule, you cannot distinguish between these 4 bonds. Although one of them is coordinate bond, the electron is shared only from nitrogen, so the hydrogen has not brought the electrons for the sharing. So these are the coordinate bond. So another example of the coordinate bond you can see in H3O plus. Okay, so the total valence electron that you have here, you have 3 hydrogen, each one of them has 1 valence electron, plus oxygen, it has 6 valence electron, and it's positive, it means the whole compound has lost 1 electron. So the total valence electron for these ion becomes 8. Oxygen come to the center, hydrogen, hydrogen, single bond hydrogen. You have to make the oxygen octet 1, 2, 3, 4, 5, 6, 7, 8. And if you count the electrons, the total valence electron is 8, same as what you have here. So it means this is the correct Lewis structure for H3O plus. But which of these bonds are coordinate? At least one of them is coordinate. How do we know which one, or if the coordinate bond is available or not? So the central atom is oxygen. The oxygen has 6 valence electrons, so it needs only to share 2 electrons to become octet. Okay, so 1 electron is shared here, the other one is shared here. So it means the other one is the coordinate. So it has 6 valence electron. If it shared its 2 electrons with the other hydrogen, 4 electrons remains for itself. 2 of them are here, 2 of them are here, and 2 of them are shared from one side with the hydrogen or with the H plus. So this is the coordinate bond between the oxygen and one of the hydrogens. So let's go back to your textbook. It says the example 4 involve covalent bonds where each bonded atom contributes 1 electron to shared pair. However, sometimes the bond forms by both electrons in the pair originating from the same atom. It means only one of the atoms shares the electron. The other one doesn't bring anything for the sharing. Okay, this is called coordinate covalent bond. Okay, so the examples of the coordinate covalent bonds are mentioned here. So you have H3O plus, which we have explained about that, NH4 plus, and also you have CO. So let's talk about the CO here. So let's draw the Lewis structure for the carbon monoxide. So total valence electron for the carbon monoxide. Carbon has 4 valence electron, oxygen has 6 valence electrons, so the total valence electron is 10. So we draw these molecules, we put a single bond between them. We have to make all of them octets. So let's start from the oxygen at the right side. It has 2, 4, 6, 8 valence electron, 2, 4, 6, 8 valence electrons. If you count the electrons, you can see that you have 14 electrons here in this Lewis structure. So this is not correct Lewis structure because totally we must have 10 electrons. So as we said, in this case, you cancel a lone pair from one of the atom, you bring from the adjacent atom between them, but we have to cancel 4 electrons because the total electron in this structure was 14. So now it reduced to 12. I cancel this one, I bring from the adjacent atom between them, so now it becomes 10. The correct Lewis structure that we have here is C triple bond O. 1 lone pair remains for the oxygen, 1 lone pair remains for the carbon. Okay, one more time here. Look at the oxygen. Oxygen has 6 valence electron. So it needs to share only 2 electrons. If it shares only 2 electrons, it becomes octet and 4 electron remains for itself. So 2 plus 4 becomes 6. So it shares these 2 electrons. 4 electron remains for the oxygen. 2 of them are here and 2 of them are here, which are shared from one side with the carbon. So we can show it by this arrow to emphasize that it is coordinate bond. But most of the time, because we cannot distinguish between these three, all of them are exactly the same, we just can show it by this. But actually this one, both of the electrons has came from oxygen, so that's why we can show it by this one.